Let's take a look at mass spectroscopy of the elements a little bit closer, and our goal is going to be to identify an element from the mass spectrum. So let's just hop into an example. Here is a mass spectrum for an unknown element, and I want to know what element it is. Here are the questions I want to ask myself. First off, how many isotopes are in this element, or does this element have? It has two bars. 1, 2. What are the masses of those isotopes? And really I want the range. Well, the masses of those isotopes go from 39 to 41. If I know that, I can limit where I'm looking at the periodic table in order to figure out what element this is, because the only elements on the periodic table that have atomic masses that are anywhere between 39 and 41 are argon, potassium, and calcium. Argon has a mass of about 40, potassium about 39, and calcium also around 40. So, to figure out which one of these is the right one, I want to compare the relative abundance. And what this means is look at the peak heights. This 39 makes up most of the sample, which means that the mass is going to be much closer to 39. The 41 is very small compared to it, and so it's not going to be able to pull the mass close enough to 41 or even close enough to 40. So from that, I know that it's probably closest to 39, and I'm going to pick potassium. If you kind of want to think about this in terms of something like your grades, right? If you have 10 100s, then your average is really high. And if you get 170, you're still going to stay at a really high average because most of your grades are 100, and that 170 is only going to bring you down maybe 2 points. This is what it means to be relative abundance. All right, let's take a look at a harder one. How do I deal with something more complicated? Well, that's the nice thing about these questions. They'll help you limit down your choices. So go through the questions. How many peaks are there? Well, there's 5. 1, 2, 3, 4, 5. So there's 5 isotopes. What's the range of masses that I'm looking at? Well, I'm going from 90 to 96. What elements fall in that range? Well, it can be zirconium, 91.2, niobium, 92, or molybdenum at 96. Which of these masses can I consider and which ones can I get rid of? Well, let's start with this molybdenum because it's at 96. Look at that. And at 96, I have a small amount. It's a really small peak. And so the mass probably isn't close to 96. Matter of fact, it's probably closest to 90. So I'm going to get rid of that molybdenum choice really quick. Now the other two, I have 91.2 and 92.9, which is about 93. So here's 93. If it was about 93, then I would see more peaks around 93 or a higher amount. But most of the peaks are all below 93. So I can actually get rid of the niobium because there isn't very much beyond 93 or even at 93. Everything for the most part is below. So I'm going to call this one zirconium. And this is the way that these questions can guide you to identifying the elements based on these mass spectrums.